Hello everyone, here is the test review 2 for General Chemistry 1. For question number 1, we would like to find which one of these compounds are a strong electrolyte. To identify a strong electrolyte, we need to find out strong acids, strong bases, and also ionic compound that they are soluble in water. Here we have methylamine. This is a derivatives of ammonia. So the compound that they all look like ammonia, like this example, they also have the same properties. So it is a weak base. So this is not our choice. HNO3 is an strong acid. We have 6 strong acid and one of them is nitric acid. But sulfurous acid, it is a weak acid. And Kf, potassium fluoride, it is an ionic compound and it is soluble based on the solubility chart. So these two, they are a strong electrolyte. So the answer is C. For question number 2, we would like to write the balanced molecular equation when sulfuric acid and potassium hydroxide, they react. So sulfuric acid is a diprotic acid. So H2SO4, acids and base, they form salt and water. And the salt for sulfate and potassium is K2SO4. So we can see clearly that we need 2 potassium. And here we have the coefficient 2 for potassium hydroxide. We also have 4 hydrogen and we need to have coefficient for water as well. So this is the equation we need and the answer is E. The first choice A is the net ionic equation for this reaction, but the question asks about molecular equation. For question 3, we would like to know which one is insoluble. Based on the solubility table, ammonium and group 1 of periodic table, they are always soluble, no matter what is their anion. Based on that, B is soluble, C is soluble, and E also is soluble. In addition of that, for chloride, for Cl minus, if we take a look to the solubility chart, we see that it's soluble for all cation except for lead, mercury, and silver, and magnesium is not one of them. So this is also soluble. So the answer is A, and by checking the hydroxide in solubility table, we see that hydroxides, they normally are insoluble except group 1 and some elements in group 2 of periodic table. For question 4, we would like to know which of the following compound is a weak acid. HCl is strong, H2SO4 sulfuric acid is strong, nitric acid is strong, HBr is strong. In addition of these 4 strong acids, we also have hydroiodic acid, HI, and perchloric acid, HClO4. Any acid except these 6 acids is weak acid. So HF is the answer in this question. It is a weak acid. For question number 5, we would like to find the oxidation number of chlorine in perchlorate ions. We know the charge of this ion is -1, so the total of oxidation number for all atoms should be equals to -1. We don't know Cl, so we just write Cl, and we have 4 oxygen, and we know the oxidation number of oxygen is -2. The total of this oxidation number should be -1 because the anion has -1 charge. Then Cl minus 8 is equals to -1. If I add 8 to both sides of this equation, these two cancel out, and Cl is equals to +7. So oxidation number for chlorine is positive 7. So D is the answer. For question 6, we would like to know which of these reactions actually occurs. It is a single displacement reaction and we need to check the activity series. In first reaction, magnesium used to form calcium. So we can say magnesium forms calcium. And we know the element on top of the activity series, they can form the elements lower than them. But the opposite, it won't happen. We need to check the activity series. Here is the activity series. And here we have calcium, and here we have magnesium. So calcium is higher than magnesium. So magnesium cannot form calcium. So the A, it won't happen. For B, we have cobalt and it forms mercury. So cobalt converts to mercury. Let's see if the cobalt is higher or mercury. Here is cobalt and here is mercury. So cobalt can reduce mercury ions to mercury. So B should be the answer. But we can also double check the rest of them. In C, we have copper and zinc. So copper forms zinc. And in D, we have iron and barium. So iron forms barium. Let's double check these two as well. Here we have zinc and here we have copper. So copper cannot form zinc. And also the next one was iron and barium. Iron also cannot form barium in a single displacement reaction. So the answer is B. Question 7. Which of the following reaction is combination reaction? In combination reaction, two compounds or elements, they combine and form one product. Based on that definition, the only thing we can find here is C, that hydrogen and nitrogen, they combine and form ammonia. The first reaction, it is single displacement. The second reaction, we have one compound is break down to two different compounds. It is decomposition. D, we have precipitation reaction or double displacement reaction. And C is combustion reaction because we have burning of methane with oxygen. In question 8, we would like to find the molarity of a solution if we have 51.2 grams sodium fluoride to prepare 650 milliliter of solution. So we have the mass of solute, then we have its molar mass is 41.99. So we can say 41.99 gram sodium fluoride is equals to 1 mole. So grams of fluoride, they cancel out. So the mole of sodium fluoride is equal to 1.22 mole. And based on the definition of molarity, molarity is mole over volume, and volume should be liter. So by dividing the mole by the volume, 0.650 liter, it should be in liter. Then we have the answer, which is equals to 1.88. C is the answer. For question 9, we have a dilution question. We have an stock solution with higher concentration. We would like to prepare 350 milliliter of diluted solution. So we clearly should use M1V1, M2V2. M1 is 0.720. V1, we don't know. M2, the molarity for second solution, so 0.125. And volume is 350 ml. If I want to calculate the V1, I need to dividing both sides by 0.720. Then these two they cancel out, and V1 is equals to this fraction, which is equals to 60.8 milliliter. So C is the answer. In question 10, we would like to find the spectator ions when we have reaction of nitric acid and potassium hydroxide. So reaction of nitric acid and potassium hydroxide forms potassium nitrate, which is aqueous, and water. We know nitric acid and potassium hydroxide, they are both strong, so the net ionic equation is this equation. So H, OH, and water, they are our main reaction. So nitrate and potassium, they're just balancing the charge in the reactants and product, and they are a spectator ion. So the answer is B. In question 11, we have a titration reaction. The volume for sulfuric acid with unknown concentration is 50 milliliter. And we have the volume and concentration of sodium hydroxide solution. First, let's write the equation for this titration. Sulfuric acid and sodium hydroxide. Sulfuric acid is diporotic acid. Sodium hydroxide has only one OH, so it should have 2 as a coefficient. Then the product is sodium sulfate and 2 mole water. We can use the classic stoichiometry to solve this question, but the easier way is the shortcut. In shortcut, we have to calculate the mole over coefficients for both of the compound. And when we have solution, mole is always equals to molarity times volume. So MV for sulfuric acid, or I just mark them by 1. And here we have M times V for sodium hydroxide that I mark them by 2. Coefficient for sulfuric acid, it is 1. And coefficient for sodium hydroxide, it is 2. And this one, we just ignore it. Then we can easily find the answer. We have the volume, it is 15 milliliter for sulfuric acid. The molarity for sodium hydroxide, it's equals to 0.26, and volume is 64 milliliter. 15 times M1 is equals to 8.32, and if I divided both sides by 15, then these 15s they cancel out, and M1 is equals to 8.32 divided by 15, which is equals to 0.55. So the answer is B. Here is another solution stoichiometry question. It is for precipitation reaction, formation of solid, and we can easily use the same method for solving the question. We don't know the volume of barium nitrate, we have its molarity, and we have the molarity and volume of aluminum sulfate. So we write one fraction for barium nitrate, one fraction for aluminum sulfate. M1V1 for barium nitrate, its coefficient it is 3, and M2V2 for aluminum sulfate, and its coefficient in this equation it is 1, so we just don't write it. Then M1 it is equals to 0.415, and M2 it is 0.250, and V2 it is 42. Then if I multiplying both sides by 3 and dividing both sides by 0.415. These 3 they cancel out and this number they cancel out. Then V1 is equals to this fraction. The answer is equals to 75.9 milliliter. So E is the answer. For question 13, we would like to identify oxidizing agents. In this reaction, Mn converts to Mn2. So manganese lost electron. When it's losing electron, it is oxidized. And nickel cation converts to nickel. So nickel cation in this reaction gains 2 electrons to be neutral. So it is reduced. When an element or compound is reduced, then it is oxidizing agent. And when it's oxidized, it is reducing agent. So this question asks about oxidizing agent. So nickel cation is an oxidizing agent. So the answer is D. In question 14, we would like to calculate the energy of one photon with wavelength of 895 nanometer. Here is the equation for calculation of energy, Hc over lambda. H, Planck's constant, is equals to 6.626 times 10 to negative 34. C, speed of light. We normally use 3 times 10 to positive 8. And the lambda is 895, but it is nanometer. So nano is 10 to negative 9. The answer is equals to 2.22 times 10 to negative 19. So D is the answer. In question 15, we know the electron, it is on level 7 and is emitting a photon. So it should fall to the lower energy level. And the emitting light has 396.9 nanometer wavelength. We would like to know which energy level electron moves. So what is the final energy level? Because we have R, it is easier to use the Rydberg equation. 1 over lambda is equals to R times 1 over n of final square minus initial square. And lambda is 396.9 nanometers, so we should write 10 to negative 9 is equals to R times 1 over final state, we don't know. Initial state, it's 7, so 7 square, or let's just write 49. If I dividing both sides by R, then these R's, they cancel out. And we can rewrite the equation in this form. 1 over 396.9 times 10 to negative 9 times R is equals to 1 over nf square minus 1 divided by 49 is equals to 0.0204. The value for this fraction on the left side is equals to 0.223 is equals to 1 over nf square minus this number. So I continue the calculation here. 0.223 is equals to 1 over final square minus 0.204. Then if I add 0.204 to both sides, then these two they cancel out and we have 1 over nf square is equals to 0.2434, and I need to flip this fraction, so nf square is equals to 1 over 0.2434. The value for this fraction is 4.1, or let's just write 4. So nf square is equals to 4. So n is a square root of 4, which is 2. So electron should fall from level 7 to level 2 if we want to have that wavelength as an emission. In question 16, we would like to know which electron transition in hydrogen atoms can have the emissions with highest frequency. Based on the Bohr equation, the delta is relating to the position of electrons in initial and final layers. And energy of electron is equals directly to the energy of photon, or we can write h nu. So if we have higher energy, we have higher frequency. But for this case, we don't need to use this equation. Sometimes we need, but in this question we don't, because if I write the layer 1, 2, 3, 4, 5, and so on. In A, electron moves from 2 to 4. This is not emission. Emission always electron falls from higher level to lower level. So this is not our choice. Same for B. These are absorptions, not emission. So in C, electron falls from level 5 to 1. In D, electron move from level 4 to level 2. And for E, again, we have absorption because from 1 is moving up to level 4. So N1 to N4 is not emitting anything, it's absorbing light. So between C and D, C has higher energy, so it has higher frequency. So C is the answer. Question 17. What is the angular momentum quantum number L for p subshell? L0, it is for s orbital, L1 is for p, L2 is for d, and L3 is for f orbital. So for p subshell, L should be 1. So this is the answer. Here in question 18, we would like to know which of these set of quantum number is permissible or valid. The easiest way is to take a look to the ms value, because ms, it can be only negative half or positive half. So A cannot be the answer, is not valid. 0 again is not valid. But for C, D, and E, we have the valid value for ms. Then we need to check N, L, and ml. N can be any number from 1 to infinity. So 3, 2, and 4, they are fine. But when we have 4 for N, then the value for L can be 0, 1, 2, and 3. And here we have 0. So this is also correct. And for L equals 0, the only ML we can have, it is 0. So C, it is correct. For D, N is equals 2. When N is equals 2, then L should be 0 and 1 until N minus 1, 2 minus 1. And we can clearly see here the L is 2, which is wrong as well. For E, N is 3. When N is equals 3, we can have these values for L, and so 0 is correct. And when we have 0 for L, the only value for ML we can have is 0, because it's from negative L to positive L. We cannot have ML equals 1 when we have L equals 0. So the only set is correct is C. For question 19, we would like to have electron configuration of chromium. Chromium is 24, so we need to use argon, noble gas. Helium, neon, argon. In periodic table, it's the third noble gas. So after third noble gas, we should have 4s. 2, then after 4s, we have 3d. Argon is 18 and 2 is 20. So we have 4 more electrons. So we may think this is the correct answer and then choose this choice, but it is not. Chromium and copper, they are exceptions. Because of the stability of orbital diagram, chromium would like to transfer one electron to d orbital, and 4s is changed to 4s1, and d4 converts to d5. So the actual answer it is D. For question 20, it says what is the electron configuration of elements in group 15 or 5a? When it's 5a, it means on our valence shell we should have 5 electrons. And here we have 4, here we have 5, here we have 6, here we have 5, and here we have 5. But group 5, it is not D block. From group 13 to group 18, it is P block. So after NS, we should have NP. So this is not answer and this is not the answer. So the only electron configuration we have with 5 electron is D. For question 21, we would like to identify number of single electron in zinc cation. Zinc is 30. So I'm going to write its electron configuration for neutral zinc. After argon, we have 4s2, and after that we have 3d10 to have 30 electrons. When we have zinc cation, then the 2 electrons should be taken off from the valence shell, the outer shell, which is 4s2. So 4s2 converts to 4s0, that we don't write it. And we have 3d10. d10 is completely filled with electrons, and there is no single electrons. So it is a diamagnetic cation. For question 22, we would like to know how many orbitals exist in third shell. Number of orbitals in each shell is equals to n square. In third layer, we have 3 square orbitals, 9 orbitals. One is 3s, 3 of them is 3p, and 5 of them is 3d. In total, we have 9 orbitals. Question 23. It says, what is the maximum electron capacity of fifth energy level? So number of electrons is equals to 2 times number of orbital in each level or shell. So 2 times, we want to find it in fifth energy level, so 5 square. 5 square is 25. 25 times 2 is 50. So the maximum capacity of fifth energy level is 50 electrons. In question 24, we would like to find which of these elements has the largest atomic size. The term for atomic size in a periodic table from left to right is decreases, and down in one group it increases. So the elements on the right and top, they are the smallest element, and the elements On the left side and down, they are the larger ones. And if we take a look to the periodic table, we can see that the germanium, it is the lowest one and it is on the very left between these 5 elements. So germanium is the answer. For question 25, a story is a little different. Because we have cation and anion, we cannot follow this trend. We need to identify the number of electrons in each species. Potassium is 19 and lost 1 electron, so it has 18 electrons. Rubidium is 37 and lost 1 electron, so it is 36. Bromine is 35 and it's negative, so it has 1 extra electron, so it is 36 electron. Chlorine is 17 and with 1 extra electron it is 18 electrons. And krypton is neutral and it has 36 electrons. So potassium and chloride, they have 18 electrons, so they are look like argon electron configuration. And krypton is lower than argon, so argon for sure it is smaller. So one of these chlorine or potassium should be the smallest one here because we have only 18 electrons. So when we have isoelectronic species like these two, the one with more protons or more atomic number, it has the smallest size. So because potassium has more proton, then it has the smallest size and it is the answer. For question 26, we would like to find the largest ionization energy among these elements. For ionization energy, we have these terms. From left to right, ionization energy increases, and down in one group, ionization energy is decreases. So we expect to have the highest ionization energy on the right and top of periodic table. So we may think oxygen it is the answer because it is on the very right and top of the periodic table. But oxygen it is next to the nitrogen. And nitrogen is group 5 and oxygen is group 6. This terrain it is a general terrain, but there were 2 exceptions. Group 5 ionization energy is higher than group 6. Same thing for group 2, like beryllium is higher than group 3 boron. These two groups they are exception. So instead of oxygen, our answer should be nitrogen. We would like to identify the element at the second period that has this series of ionization energy. When we take a look to these ionization energy numbers, we see a big spike or jump in the energy when we move to the fourth ionization energy. Is like 8 times higher than third ionization energy. So this means these 3 steps, it was on the valence shell. And when we have a very big jump in ionization energy, then we move to the inner layer. So based on this logic, our elements should belong to group 3 because after removing the third electrons, then we have a big jump in ionization energy. So group 3, it is boron, aluminum, gallium, and so on. The element on second period, it is boron, B. So the answer is D. Question 28. We would like to know which of these diagrams are correct for P4. P4 we have 3 orbitals and based on the Hund's rule, we should start to put 1 electron in each orbital and they should be the same spin. Then because we don't have any more orbital, we need to start over again and put the 4th electron because we have 4 electrons. So this is the correct orbital diagram for P4. So B is the answer. A is violating Hund's rule. C also violating Hund's rule because these two spin, they are not the same, they are not parallel spin. And D is violating Pauli exclusion principle because we have two electrons with same spin inside one orbital, which is wrong. For question 29, we have a series of cations and we would like to know which one is diamagnetic. We need to write the electron configuration for all of these ions. Iron is 26. Its electron configuration is argon 4s2 3d6. So when we have iron 2, we're just losing these two electrons. So d6, we have 4 single electrons. So it is paramagnetic. So A is not the answer. Because we have iron 3 here, then if I remove another electrons for having iron 3 electron configuration, still we have single electron and it is not diamagnetic. Copper 1. Copper is 29 and its electron configuration is another exceptions like chromium. It is 4s1 3d10. So d10 is completely filled. There is no single electron. And when we remove one electron, 4s losing that electron. So all electrons, they are pair and there is no single electron. So copper 1, it is diamagnetic. And the last question, question 30, we would like to know which of these subshells or orbital has the lowest energy. In general, when in one layer, S, it has lowest energy than P, P lower than D, D lower than F. So between 4S, 4P, 4D, and 4F, for sure, these three have higher energy level. But here we cannot say because it is D, it has higher energy level. We have to take a look to the Aufbau principle. Regarding to the Aufbau principle, 4s is occupied first with electron. After that is 3d. So this means 4s orbital, it has lower energy than d orbital. So the answer it is A.